Assalamualaikum warahmatullahi wabarakatuh. My name is Eltera. I am from PESB 2024. In this video, I will show you my demonstration video, which is about thermodynamics phenomenon. So, stay tuned. Part A, which is demonstration title. My demonstration title is the relationship between temperature and gas pressure in a closed system based on Gay-Lussac's law. Title explanation. This demonstration title directly reflects the core of the physics phenomenon being shown, which is how changes in environmental temperature directly affect the pressure of gas trapped inside a closed system. In this experiment, the closed system refers to a sealed glass bottle whose volume remains unchanged throughout the experiment. The word thermodynamics refers to the branch of physics that studies the relationship between heat energy and mechanical work, particularly in gases. The phrase relationship between temperature and gas pressure highlights that the main focus of this experiment is observing how these two physical quantities are directly related to one another. The phrase in a closed system emphasizes that the volume of gas inside the bottle is kept constant throughout the experiment. So, only temperature and pressure can change, which is the key requirement for Gay-Lussac's law to apply. When the bottle placed in hot water, heat energy transfers to the air inside. The temperature rises, pressure increases, and the colored liquid in the straw is pushed down. Conversely, when the bottle is moved to cold water, the temperature drops, pressure decreases, and the liquid rises up the straw. This rise and fall of liquid in the straw is the visual proof of Gay-Lussac's law. The materials used in this demonstration are simple and easy to find at home. Namely, the first is one clear glass bottle of medium size. It serves as the closed container where air is trapped, keeping the volume of air constant throughout the experiment. The second is one clear or transparent plastic straw. Serves as a visual indicator of pressure changes. The rise and fall of liquid inside the straw shows changes in air pressure within the bottle. Third, plasticine or modeling clay. It serves to seal the gap between the straw and the bottle cap so the system is completely airtight with no air leakage. Fourth, colored water or water plus food coloring serves as a visual marker so that the movement of liquid inside the straw is clearly visible to the camera. And the fifth is hot water in a basin or bowl. Serves as a heat source to raise the temperature of the air inside the bottle, causing pressure to increase. And sixth or the last is cold water or ice in a separate basin or bowl. It serves as a heat absorber to lower the temperature of the air inside the bottle, causing pressure to decrease. Okay, the next is part C, which is demonstration objectives. This demonstration aims to first is visually demonstrate how changes in temperature at constant volume affect the pressure of gas in a closed system. Second, qualitatively prove that when the temperature of gas in bottle increases, the gas pressure increases, push the liquid in the straw downward in accordance with Gay-Lussac's law. Third, qualitatively prove that when the temperature of gas in the bottle decreases, the gas pressure decreases, pulling the liquid in the straw upward, also in accordance with Gay-Lussac's law. And the fourth, which is the last, provide a concrete understanding of how Gay-Lussac's law applies in everyday life through a simple, easy, and visually engaging experiment. We continue to part D, which is the part of supporting theory of this demonstration video. So, the first is Introduction to Thermodynamics. Thermodynamics is a branch of physics that studies the relationship between heat, energy, work, and the properties of matter, particularly gases. The word thermodynamics comes from the Greek word therm, meaning heat, and dynamics, meaning power or force. In essence, thermodynamics deals with how heat energy can change and transfer, and how those transfers affect the physical properties of substances, especially gases. This bottle and straw experiment is one of the simplest yet most powerful examples of thermodynamic principles observed in real life. And the second is gas in a closed system. Gas in a substance whose particles move freely in all directions and tend to fill all available space. When gas is placed in a closed, sealed container such as a tightly capped glass bottle, it cannot escape or be added to. In this condition, three main gas properties are closely interrelated: temperature, pressure, and volume. In this experiment, the rigid glass bottle ensures that the volume of air inside remains constant throughout, with volume held constant. Only temperature and pressure can change. When temperature rises, gas particles move faster and collide more frequently and forcefully against the bottle walls and surface of the liquid in the straw, resulting in increased pressure. Conversely, when temperature drops, particles slow down, collisions weaken, and pressure decreases. Okay, the third is Gay-Lussac's law. Gay-Lussac's law is a thermodynamic law proposed by French scientist Joseph Louis Gay-Lussac in 1808. The law states that at constant volume, the pressure of gas is directly proportional to its absolute temperature, or in Kelvin. This means that if the temperature of gas is increased, its pressure increases proportionally, and if the temperature is decreased, the pressure decreases as well as long as the volume of the gas remains unchanged. This is precisely what happens in the bottle and straw experiment. The volume of air inside the bottle is kept constant because the rigid bottle is sealed airtight. When the bottle is placed in hot water, the air temperature inside rises. According to Gay-Lussac's law, the air pressure also rises, pushing the colored liquid in the straw downward or even out the straw. When the bottle is placed in cold water, the air temperature drops, pressure decreases, and the water atmospheric pressure outside pushes the liquid upward through the straw. This rise and fall of the liquid qualitatively proves the validity of Gay-Lussac's law. And the fourth is heat transfer or conduction. For Gay-Lussac's law to take effect in this experiment, heat energy must transfer from the surrounding environment, or hot or cold water, to the air inside the bottle. This heat transfer occurs through a process called conduction, which is the transfer of heat through a solid material from a region of higher temperature to a region of lower temperature. In this experiment, heat travels from the whole water to the glass bottle wall, and then from the bottle wall to the air inside. This conduction process continues as long as there is a temperature difference between the water outside and the air inside the bottle. The longer the bottle is submerged, the more heat transfer, and the more noticeable the pressure change and liquid movement in the straw. Okay, we're at the part of the demonstration process. First, we must fill the bottle partially with colored water, then insert the straw into the bottle. After that, seal the mouth of the bottle tightly using plasticine to ensure no air can escape so the system is nearly constant in volume. place the bottle into the container filled with hot water and observe the movement of the liquid in the straw. Record the changes in the liquid level as the temperature increases. After that, remove the bottle and place it into the container filled with cold water. Observe and record the movement of the liquid in the straw as the temperature decreases. And compare the results obtained in hot and cold conditions. Okay, we are now at demonstration results. The results observed during the demonstration are qualitative in nature, based solely on visual observation without numerical measurement. A. When the bottle is placed in hot water, the liquid in the straw rises or is pushed out because the air expands or pressure increases, and the liquid also expands, consistent with Gay-Lussac's law. And B. When the bottle is placed in cold water, the liquid falls or is pulled into the bottle because the air contracts or pressure decreases, and the liquid also contracts, also consistent with Gay-Lussac's law. And C, which is the last, the greater the temperature difference, the greater the change in air and liquid volume, making the liquid movement more noticeable. Okay, now we in part of conclusion. So, the conclusion of the demonstration is, based on the demonstration that has been carried out, it can be concluded that Gay-Lussac's law is qualitatively proven, where at constant volume, gas pressure is directly proportional to its absolute temperature. An increase in temperature causes an increase in pressure, while a decrease in temperature causes a decrease in pressure. The downward movement of liquid in the straw when the bottle is placed in hot water indicates an increase in gas pressure due to a rise in temperature under constant volume conditions. The upward movement of liquid in the straw when the bottle is placed in cold water indicates decrease in gas pressure due to a drop in temperature under constant volume conditions. And then, this demonstration shows that thermodynamic concepts, particularly Gay-Lussac's, can be directly observed through simple experiments using everyday materials. Okay, I think that's all for my demonstration video. Thank you for watching and wassalamualaikum warahmatullahi wabarakatuh.